Okay, let's do a proof here. I wonder if I can prove if triangle EFH is congruent to triangle GFH. They sure look like they're congruent, but proving something is a little different. If I want to prove that triangle EFH is congruent to triangle GFH, I need to prove that three sides match three sides. Well, by looking at this, I can see that two of the sides match. These two match, and these two match. I just need a third side. Let me start writing down what I know. When you do a proof, sometimes you write it like this: the statement and a reason. Well, when I look at this figure, I know that segment EH is congruent to segment GH because they're marked that way. See the little mark? I also know that EF is congruent to GF also because they're marked that way. I'm just going to write that over here. Well, what about this middle piece, HF? That's in both triangles. Doesn't HF have to be congruent to itself? It makes sense. In fact, in math, that's called the reflexive property. Segment HF has to be congruent to itself. Now I've got three sides matching up with three sides. Therefore, triangle EFH has to be congruent to triangle GFH because of side postulate. And when you look at this, there's a lot of abbreviations here. It makes it look confusing, but really it's what we know. The triangles are congruent because all the sides match. I know this side matches this side, it's marked that way. I know this side matches this side, it's marked that way. And I know that middle segment's got to be equal to itself. That's the reflexive property. Therefore, those triangles are congruent by side.